Number 6 from the Rotational Equilibrium worksheet. Temporary bridge consisting of two massless planks. The 480 Newton person stands 3 meters from the end of the upper board, which itself is on rollers. What are the reactionary forces at A, B, C, and D? So if you're looking at this, there would be a weight force downward here. There would be an upward reactionary force from B here. There would be an upward reactionary force from B here. I'm not drawing these to scale. They obviously wouldn't be the same size. By Newton's third law, there would be an equal and opposite force on this bottom board here as that one. Call that also FB. There would be a reactionary force from C here, and there would be a reactionary force from A here. Again, I'm not drawing these to size. Scale, because this obviously would be smaller. So if we're looking at this, let's just first look at the top board right up here. For this, I can say that FB plus FD would have to be equal to that weight, which is 480 newtons. But clearly that's not enough information to figure out either one of those. So I need to use the second condition of equilibrium. Let's say this is the pivot point. If I set that to be the pivot point, then the torque that one creates will be 0 because the lever arm is 0. So this torque here would be counterclockwise, so the torque from force D minus this torque from the weight would be clockwise, so the torque from the weight has to be 0. The net torque has to be 0, it's in rotational equilibrium. And so I've got the force of D times the distance away, which would be 12 meters, has to be equal to the weight force of 480 newtons times the distance away that it is, which is 9 meters. I can solve this for force of D, and I get the force of D to be 360 newtons. Once I know that that force is 360 newtons, I can plug up into this original equation here, and I get the B force to be equal to 120 newtons. Once I know that this is 120 newtons, then I can start concentrating on this bottom board. This force right here is 120. Again, I can do the exact same thing that the force, I think I'll do it right here, force A plus force C has to be equal to that 120 newtons. That's not good enough to solve the problem. So let's put the pivot point right here. That will eliminate the torque from this FA force. And so I can say the torque that this one creates, which will be positive. So torque from FC minus the torque from FB has to be equal to 0, because again it's in rotational equilibrium. So this is going to be FC times the distance away, which is 12 meters, minus the force FB, which is 120 newtons, times the distance away. This is 4 meters here. The whole thing's 12 meters, so 12 minus 4 is 8 meters. So 8 meters equals 0. I can solve this for FC. And when I do that, I get FC to be equal to 80 newtons. Once I know that 80 newtons, then I can stick that in over here for FC, and I get FA to be equal to 40 newtons.